U-Substitution with Inverse Trigonometric Integrals. Okay, this is another bad title, but we have three patterns we're trying to look for that involve inverse trigonometric functions. They are 1 over the square root of a squared minus u squared du is equal to the arc sine of u over a plus c. Second, 1 over a squared plus u squared du is equal to 1 over a arc tangent u over a plus c. Integral of 1 over u square root of u squared minus a squared du is equal to, let me clean that up a little bit, it's hard to read, u squared minus a squared du is equal to 1 over a arc secant of u over a plus c. Now, two things. Yes, the arc tangent and the arc secant have the 1 over a in front. The arc sine does not. It took me forever in high school to remember and not mess up. Okay, so these two fit the arc sine function pattern. So I'm going to look for a u, and that's going to be 3x, because 3x squared is 9x squared. Du is going to be 3 dx, and a would be 1. So 1 squared is a squared, that's u squared. I need a 3 and a 1/3 to make that work. So it's 1/3 the integral of 1 du over the square root of a squared minus u squared. So I get 1/3 arc sine of u over a plus c. So we get 1/3 arc sine, let's see, 3x over 1 plus c. And of course we could write arc sine like that, right, instead? Okay, let's move the paper over just a bit. U equals 7x, so du is 7 dx, and a would be 4 in this problem. So that'd be a squared, that'd be u squared. I need a 7 dx for my du, so I need a 1/7 in front, right? Okay, so I get 1/7 integral. Let's see, du is there, square root a squared minus u squared, so I get 1/7 arc sine of u over a plus c, or 1/7 arc sine of 7x over 4 plus c. Okay, these rules are very important. Alright, 3 and 4. Okay, these fit the arc tangent pattern. Okay, so I'm going to rewrite that rule. 1 over u squared plus a squared du, 1 over a arc tangent of u over a plus c. Okay, so u is 4x, du would be 4 dx, and a would be 1. So in this integral I have a squared, u squared, need a 4 and a 1/4 to make this my du. So I get 1/4 integral 1 over a squared plus u squared du. So that's 1/4 1 over a arc tangent of u over a plus c. So a was 1, so I get 1/4 arc tangent of 4x over 1 plus c. You notice I keep changing how I write my arc trig functions, and that's okay. So u equals 5x, so du is 5 dx. Oh cool, I already have a 5 dx. A is 3, and so notice I have a squared plus u squared du. So I get an integral 1 over a squared plus u squared du. So that's 1 over a arc tangent of u over a plus c. So I get 1 over 3 arc tangent of 5x over 3 plus c by just following the rule. You're going to find there are a lot of integrals you can take by just knowing the rule from the table. Alright, two more. These ones follow the arc secant rule, and the arc secant is 1 over u square root of u squared minus a squared du, which is equal to 1 over a arc secant of u over a plus c. Okay? So u is equal to 2x, du would be equal to 2 dx, and a is equal to 1 here. So that's a squared, that's u squared, that's u. And let's see, I need a 2 there. So that means I need a 1/2 on the outside, yeah? Okay, so I get 1/2, let's see, let's verify things, u squared, a squared, okay. So I have 1/2 integral of 1 over u square root of u squared minus a squared du. So I get 1/2, 1 over a arc secant of u over a plus c equals 1 over 2, 1 secant, arc secant of u over a plus c. You can check that using derivatives. Okay, last one, u equals 5x, so d equals 5 dx, and a would be 2. So notice I have u squared minus a squared, that's u. Well, here u needs a 5, so if I put a 5 down there, I have to put a 5 on the outside. And I need a 5 dx there, so I need a 5 down there. Well, that's just 1. Or I could just view it as 5 over 5 as 1. Okay, so I get 1, let's see, that's du, and that's u, square root of u squared minus a squared. So I get 1 over a arc secant of u over a plus c. I get 1 over 2 arc secant of 5x over 2 plus c. So these aren't too bad as long as you could recognize patterns and see rules.